Okay, so now once we are done with this step, okay, we are done with the forward elimination of elements of the first column, we move to the second one. Okay, so now the second step is to do forward elimination for these two elements. Okay, so now we will update we will find what are F32 and F42. Okay, since 8 is the highest element between these two, so already no need for pivoting. So F32 will be 1 over 8, and F42 will be 2 over 8. And now we will proceed to do the changes for the elements here. Okay, because now when we do forward elimination, this term will become 0. And now to see what are the updated value here. So this one, 6 will become 6 minus. Now your pivot equation changed. Okay, this is your updated pivot equation. Okay, so it becomes 6 minus F32, which is 1 over 8, times the element in the pivot equation just above it, and in the row, in the pivot element, in the pivot equation, in the same column, which is 2. So minus 1 over 8 times 2. And for this term, it is 4 minus 1 over 8 times minus 3. Okay, now once we update these two, we can move now to the second step. So let us see them here, the steps. So as I told you, these are the two updated elements here. Okay, now once we are done, we will move to the elimination of this term here to get a 0 here. So now we will use so here we will use F42, okay, which is 2 over 8, which is 1 over 4. So then we can update the following coefficients. So this one will be replaced by 2 minus 2 over 8 times, we are still working with this equation as pivot equation. Okay, so the element here in the same column of 2 in the pivot equation is 2. So it's minus 2 over 8 times 2. And now for this element, it will be, which will give you 1.083. And now for this element, we'll replace it by 6 minus 2 over 8 times the element in the pivot equation that is in the same column of 6, which is minus 3. So you will get 6.125. Okay, now I completed until now. I still just have to complete my L and U. I still need to find F43. Okay, and to update now, I will do forward elimination for the last step to get here a 0 and to find what will be the updated coefficient here. Okay, so this is the last step to do. Now in my last step, okay, I have the pivot equation. So you know that the pivot equation will change when the row is locked. So this row is locked when you update these three, when you have 3 zeros here. Then this row will be locked when you update these two. And finally, the third pivot equation you will use is this one. Okay, so in the last step, this will be your pivot equation. And your forward elimination factor will be the following: F43 is equal to 2 over 6, because already no need for pivoting. This element is larger, so 2 over 6. So now you completed your L matrix, okay, because you know all factors. And then to finally to get this element, all you have to do is to say that it's equal to 6 minus 2 over 6, which is F43, times the element in the pivot equation that is in the same column of 6, which is 4. And you get then that it's equal to 5.307. Now you are done with the LU factorization process. You can write now that A can be written as the product of this matrix L times this matrix U. Now once this is done, we will find the solution to solve for X. We will do it in 2 steps: forward substitution and backward substitution. We will understand how. But now the idea is that in case B will change, vector B will change, you should do this procedure 1 time. So you do it once to decompose A in L and U. And now, whatever is B, I will develop a general method to solve for B without repeating this work. While in Gauss elimination, if I change B, I should repeat the forward elimination procedure, because each time I should update B again, okay, with the forward procedure. On the other hand, here I did separation of what I am doing for A and what I am doing for B. I'm not putting them in one augmented matrix and performing forward elimination. No, I just did forward elimination for A to write it in this form. And now I will develop a technique that will allow me to solve for X, whatever is B. And if I change B, I can use same L and U. Okay. And then I can find B without needing to do the Gauss elimination from 0 again. Here, in this slide, we will understand how we do this. So you know that your initial form is A times X equals to B. Now what we did is that we wrote A in a form of L times U. L times U times X equals to B. Okay? Now, what we will do now, we will say that I will consider first U times X. Okay? This this product, okay? I will name it. It will result in a vector of 1 column. Okay, because when you multiply here, when you multiply U times X, okay, the number of columns of this result will be equal to the number of columns of X vector, which is 1. Okay, so if we name this product U times X, if we name it D, okay, then what we can do, we can find first D, and once we find D, we then find X. And D will vary with what? With B. So now I can change B. If I give you several values of B, what will change is D. So I can get different D, and from different D I can get different X, while my this matrix will be fixed. It will not change. Okay, and this will facilitate a lot the calculation for me. Okay, so once I get my L and U, whatever is the B they give me, I can solve in a fast way. How to do so? First, I say L times D is equal to vector B. Okay, so now whatever is B, I can find the corresponding values of D in a very efficient way, because this form is very simple. Now this form we call it here forward substitution. Why? لأنه you will start from the first equation to solve. Yani since here you have zeros, this equation will give you D1 equals to 1. And once you find D1, you substitute into the second equation. Second equation here minus 1 over 6 D1, which is 1, okay, plus D2 equals to minus 1. So D2 is equal to minus 1 plus 1 over 6. Since you start to solve for D1, then you substitute to get D2, then you substitute D1 and D2 to get D3, then you substitute D1, D2, D3 to get D4. This is called forward substitution because we started from the first, we solved for D1 and then we moved forward to solve for D2, D3, and D4. Okay, so this is called the forward substitution step. When you perform the forward substitution step, you can solve for D. And as you can see here, if you vary B, the variation of B will just affect D. So I don't care if I vary B a lot of times because I can just easily take into account this variation by calculating the corresponding values of D vector. And once I have D vector, I am ready to calculate my solution to find my X vector. So all I have to do then is to say that going back to my system, okay, if you remember, the idea was to divide it in this way, L times U times X equal to B, and to set U times X, I replace it by vector D. So now when I am done with D, when I find D, okay, I can say now that to find X, all I have to do is to say that U times X is equal to D. Okay, so now I know it, it's my upper triangular matrix times X equal to D. So now I can solve for my vector X. Now I will use backward substitution because if you look at your form, you have an upper triangular matrix times vector X equal to vector D. Okay, so now as we proceeded before, we will do backward substitution to get my X factor. So I start by X4. So for example here, 5.307x4 is equal to D4. So I calculate X4. Once I have X4, I substitute into my equation, I get X3. Then I substitute back in the second equation, X3 and X4 by their values, I get X2. And finally, I get X1. Okay, let me check for your questions. Said, what we do is the first step to do is to get L and U. Okay, once you get L and U, what you do is you go back to your equation and you say, now I can replace A by L and U. Okay, so now this is your form. This is your form, LU times X equals to B. Okay, now what you will do in the next step, if depending on B, this term, this will change. Yani, the product U times X, I will call it D. D will change with B. Okay, this is why if I give you several values of B vector, all you have to do is to find what are the corresponding D vectors. Okay, yani the first step after finding L and U, you say I will find what is D. So L times D equals to B. Okay, and this system is very simple to solve because you can solve it as we have seen by forward substitution. Okay, so depending on B, what will change, L is fixed for all vectors B, L is fixed. What will change is D. So you can find the resulting D vectors, and once you find D, you say, you go back to your equation, you say D represents U times X, and U also is fixed. So what is changing from one operation to the other is B, and when B change, D will change, and this will result in a new solution, vector X. This was your question? Okay. شربل ده لازم تاخد وقت. يعني you should try to do it. Okay, هلا أنا يعني I will you should be familiar with the procedure. Once you are familiar with the procedure المفروض تاخد وقت كتير. Okay. هلا أنا I will not give you very large matrices. يعني I will give you something to finish on time. Okay. So as we said, the forward substitution will give us D vector. And once we have D, using backward substitution, we solve for X. So this is the idea of LU factorization. It will allow me to solve for different right hand side vectors in an efficient way. يعني بدل اذا ما غيرت لكم ب اذا بدكم تستعملوا بس elimination كل ما غير ب بدكم ترجعوا تعيدوا elimination from zero لانه to update all coefficients. Okay, then instead of doing this, no, you will say I will develop this technique. So I separate the procedures. I do forward elimination only for A, and once I do this elimination for A بيطلع لي matrices L and U which will not change. What will just change is if I change vector B, I find first the corresponding vector D, and from this vector I find vector X after D. So if we wish to solve for a different right-hand side vectors, then we do not have to repeat the LU factorization. We need only to perform forwards and backwards substitution. So it's much more computationally efficient. Now, we will see that, okay, so in this example, for example, if we take any vector B1, B2, B3, B4, it can be related to D1, D2, D3, D4, so we can calculate the resulting. So here you can find a general relation between B and D. Okay, so for example here, D1 is equal to B1. And once I find D1, then I will say that I have minus 1 over 6 B1 plus D2 equals to B2. So as you can see, you have a dependence between vectors B and D. Okay, from these equations, you will always have a relation. So you just, if I change B1, B2, B3, B4, D1, D2, D3, D4 will vary accordingly. And then X will also vary accordingly. Okay, while these two matrices will be fixed. So I just have to find them once, and then if I change B, all I have to do is forward substitution followed by backward substitution. Now, this can be more complex if I have pivoting. Okay, so until now, we have seen a procedure, but it didn't involve any pivoting. What if in the forward elimination procedure I have pivoting? What should I do? So if we pivot during the LU factorization process, then this information, pivoting of rows, must be relayed to the right-hand side vector. Okay, so all pivoting performed should be done also for the right-hand side vector. This is why, in order to track pivoting, we can keep track of this pivoting through a permutation matrix P. Okay, so then we can, at the end of our result, we can write, instead of A equals L times U, we write matrix P times matrix A equals to L times U, where P will consider the different pivoting actions we did. Okay, so this is called permutation matrix. So it will permit for us to track all pivoting procedure. Now, how to perform this? We will take an example so you can understand the procedure better. So let us consider the following matrix A, and we will perform LU factorization with partial pivoting when needed, of course. Okay, so to start with, the first step is to perform forward elimination for these elements, for elements in the first column. Now, before starting the process, we will see if this pivot equation is convenient or not. So if I consider this is my pivot equation, my pivot element will be 2, but 2 is smaller than 3 and smaller than 11. So it's not the best choice. Okay, the most appropriate choice is to consider this is my pivot equation because it has the largest pivot element in absolute value. So now I will say I need to pivot for the first and the fourth rows before starting my forward elimination procedure. Okay, and now to track this, I will consider first the matrix P with ones on diagonals. So it's a very simple matrix, 1 on diagonals, and all remaining terms are 0. And this matrix, since it will track my pivoting, when I do pivoting of the first and fourth rows in my A matrix, I will say also for P, I will do this. I will pivot the first and fourth row. So now the permutation matrix P is the following one. Okay, and in this way, I will know at the end. Okay, what is the total? If you want the resulting pivoting matrix P. And once I have the pivoting matrix P, I can multiply P by B, okay, to get the corresponding vector. So this is the first step. Whenever I do a pivoting in my matrix A, I do it also in P, okay? Now, this will allow me to transfer this information at the end at the end of the factorization process for vector B, and we'll see how, okay? Now I can start with my first elimination step. Okay, if you go back to your matrix here, now this system, this equation, this matrix A will become 11, 3, 2, 5, 3, 0, minus 8, 4, minus 2, 1, 1, 7, and the last row here, because we pivoted these two, it's here 2, minus 6, 0, 1. Okay, now from here I can start to perform the forward elimination procedure. So I can say now I can know factors F21, F31, and F41. Okay, I can know them because simply F21 is A21 over A11, so it's 3 over 11. F32 is A31 over A11, so it's minus 2 over 11. And F41 is A41 over A11, so it's 2 over 11. So now my matrix, I will start by building my matrix L. My matrix L has always ones on diagonal, zeros in the upper part. And now I start to fill my matrix L. So this is F21. This is F31. And this is F41. Okay. Now, how to proceed? Now I will do the forward elimination. Okay, to update my these elements, these coefficients here. So as usual, okay, as usual, what I do is, for example, I say this element will become, it was 0, it will become 0 minus, what is the first factor? It's 0.2727, 3 over 11. So minus 3 over 11.
دكتور في كده انا ما عرفتش جديد لانه عجقت شوي ما عم بقشع.
Yes, I will. Okay. أول شيء فهمت this part how we replaced F21, F31 and F41.
ايه اكيد هيدي ايه اكيد.
Okay. Yeah. So going back للماتريكس. Okay. Your matrix here, the updated one هيكون هون instead of these elements you have 11 3.
مظبوط عملنا pivoting لانه ال 11 اكبر. مظبوط.
طيب هلا كيف بدك تكمل الفورورد elimination? You should update the coefficients. مظبوط. يعني نحن هون the first step of forward elimination هي تنحط 0 here صح؟ To have a 0 here, what is the factor you used? You used the factor F21 equals to 3 over 11.
3 over 2.
Okay. So now you want to update these coefficients here. هيدي الزيرو شو رح تصير؟ 0 minus 3 over 11 times what? مين كان عم يحكيني؟
انا شربل دكتور. لا هون ما فيش مشكله، هودي بعرفهم من قبل بس.
طب ما شو عملنا يا شربل؟ ما شو عملنا؟ بعد ما عملت شيء يا شربل، ما عم بعمل هولي، بعد ما عملت شيء. شو هو اللي ما فهمته على المضبوط؟
البي ما عرفت شو عملنا فيها.
ما بعد ما وصلنا للبي. البي بعد ما حكينا عنها شربل اخر شيء ويل ابديت. اوكي؟
لا دكتور البي
البي اوكي البي يس. البي انت initially البي قبل ما تعمل any pivoting البي بتكون like this 1 1 1 1 والباقي 0. اوكي هيدي الماتريكس بي before any pivoting procedure. هلا انت الاي تقدر تعمل forward elimination in an efficient way. شو عملت بالاي؟ you just pivoted the first and fourth rows صح؟
ايه مزبوط.
اوكي لازم تعمل نفس الشيء ببي، يعني كل pivoting بتعمله على A لازم تعمله على P. بما انه you did the exchange بين 1 and 3 you did pivoting between 1 and 4 rows you should do it for P also. يعني بدك تقلب هول الاثنين. فالupdated P matrix بتصير 0 0 0 1. اوكي تاني
اوكي بدلنا اخر رو باول رو. مزبوط
بس هيدا اللي عملناه لحد هلا. اوكي يعني هيدا البي كل ما تعمل بيفيتنج بتعمل على A بتعمله هو ذاته على P لانه هي بتحفظ كل البيفيتنج اوبريشنز in this way. اوكي
اوكي دكتور ميرسي.
اوكي so now for example وقت نعمل forward elimination هيدا الترم شو بيصير؟ هيدا الترم بيصير 0 minus 3 over 11 times ما تنسوا انه هيدي صارت فوق يعني times 3. اوكي وهيدا الاليمنت بيصير minus 8 minus 3 over 11 times 2 and this one will become 4 minus 3 over 11 times this one times 5. okay etc. يعني البروسيجر صرتوا تعرفوها كيف. so now as we said whenever I do pivoting I do it also for P. يعني صارت عندي already ال P بدلنا ال first and fourth row وبالنسبة لل L بلشنا نعبيها. okay and now after performing the first step الأول forward elimination يعني we update the coefficients هون مثل ما شفنا بالتكنيك. okay we do it for أول شيء for the first step لما عملنا forward elimination for this term يعني بنستعمل ال F هون F21 بهيدي الرو بنستعمل F31 to update these coefficients. For this row we use F41. okay now we are done with the first step يعني already خلصنا من forward elimination of the first column. now this once we are done with this هيدي row is locked we cannot work with it anymore. بتصير ال pivot equation تبعنا هي second equation. this will be our second pivot equation. okay هلا بدنا نتأكد إذا we need to do pivoting or not. okay بدنا نتأكد we will compare in absolute value مين أعلى شيء between this term and this term.
the pivoting or number 6 to 0.
yes it's not the highest one يعني هيدا هو لازم يكون هيدا لازم يكون ال pivot element in absolute value هو أكبر شيء minus 6.5 5455. so now we should pivot the second and the fourth rows. اوكي
كيف هون بي بتصير 4 محل 2 بالبي.
مظبوط فكمان بي whenever we do a pivoting بال A we should do it for P. okay so now for P also ومش بس ل P اوكي ل L كمان انتبهوا يعني اثنيناتهم لانه كل هول الماتريسز حنستعملهم اخر شيء مع بعض. يعني انا when I update P كمان I update L. هلا ليش ما عملناها فوق؟ لانه already فوق جبنا الفاكتورز من بعد البيفوتينج بروسيجر. يعني انتم هول الفاكتورز جبتون من بعد ما عملتوا البيفوتينج اوبريشن باول مره. اوكي بس هلا هيدي خلصنا منها وصرنا بدنا نشتغل بهول التيرمز. فاوريدي اذا بعمل بيفوتينج ب A مجبور هلا اعمله ب L لانه حيتاثروا هول الاليمنتس ومجبور اكيد اعمله ب P. اوكي so now in my second step بما انه عملت pivoting ب A I will do the same procedure ل L. I will pivot second and fourth rows. كمان ل P I will pivot the second and fourth row. Okay. Now, once I perform this, I can continue my forward elimination. Now, my second step after doing the pivoting, okay, أول شيء صار فيني أعبي these factors, these ones, okay. صار فيني أقول إنه this is F, this is equal to F 3 2. Sorry, F3, yes, F3 2, and this is F3 4. And how I can find them? It's very simple. I go to my equation. هيدا the pivoting element. Okay. So F32 حتكون equal 1.5455 over minus 6.5455. I get minus 0.2361. Well, F34 is equal to minus 0.8182 over minus 6.5455. So I get 0.125. Okay. So now I am done with this step. Okay. عبيت هولي. So now I will update my matrix. I will perform a forward elimination for my matrix. Okay. ليكو البي اخر شيء يعني اخر شيء ليش ما عم نعمل لبي هون؟ لانه عم نعمل الانفورميشن extract in P. يعني كل شيء عم ينعمل extract in P، فاخر شيء بنضرب P ب B. اوكي؟ هلا you can اذا بتعملوا ساعتها البيفيتنج بكل ستيب ب B كمان فيكم ساعتها تستغنوا عن P. اوكي؟ بس هيدي الواي از انه بطريقه انه اخر شيء بقلبهم ب B. يعني it can be done. فيكم دغري تعملوا pivoting BB ساعتها ما في لزوم تجيبوا الماتريكس P in this case. اوكي. وان كيس بدكم اخر شيء to update، بس تقلكم شو الفكره؟ هي الفكره انه if I change B، okay, if I'm changing B several times، احسن ما كل مره بدي اقعد اعمل اخر شيء البيفوتنج للبي. يعني ما انا B حتتغير، يعني ما انا بدي اعملها step once، مزبوط؟ ما بدي اعملها كل ما بيتغير. منشان هيك to track how B will vary I will use the permutation matrix P. اوكي. يعني من بعد ما اخلص هيدي الماتريكس P حتضرب حيلا vector B I am using، لانه هيدي البيفوتنج must be also transferred to P at the end. Okay. Okay. So now the step will be to update the coefficients. Okay. من بعد ما انا لقيت الاف صار فيني اعمل update للcoefficients، اعمل forward elimination procedure to update these coefficients اللي هن لهم علاقه بالf 3 2. اوكي. وهول الcoefficients اللي هن لهم علاقه بf 3 4. So now I completed the forward elimination for the second column, and now this equation is locked. I cannot use it anymore. So I will move now to deal with the third equation. My pivot equation now is the third equation. And here also pivoting is required لأنه 8.5 is higher in absolute value than 1.277. So I should pivot rows 3 and 4. Since I should pivot rows 3 and 4, I should update the information. I should update L and P. So I do pivoting for the resulting L اللي صار عندي هلا. I do pivoting between 3 and 4, and also I update my matrix P. I pivot 3 and 4, and now I am very close to the end. لأنه now I just have to compute now this term, which is very simple to find. So if I go back to my matrix, I have this factor is equal to من بعد ما نكون عملنا البيفوتنج I find the factor اللي هو 1.277 over 8.5. So I got this element, okay, and then I will complete the forward elimination step. I get my U matrix, and now I am done. عملت ال forward elimination is completed. This is my U matrix. This is my L matrix اللي هي I updated step by step when I got the factors. This is my matrix, my permutation matrix P, which tracked all pivoting operations performed during the calculation. Okay, and now once this is done, it will become very simple. شو ما كان B إذا بيعطوني حيلا B now, what do I do? For any value of B, I say A times X is B. I replace A by P times A. Okay, لأنه أنا لأنه عم بعمل permutation، عم بعمل pivoting ل A. This pivoting هو ذاته حيكون ل B. يعني I should multiply the two sides by P. So PAX equals to PB. ساعتها شو ما كان vector B كيف ما غيرته بضربه ب P matrix P بتعطيني ال corresponding vector اللي لازم اشتغل فيه. So now once I transform it to this way رجعنا لل conventional method. يعني بس صار عندي الفector PB والvector PA هي LU. So now I will proceed as I did before. بس الفرق انه بدل ما اكون عم بشتغل مع vector B عم بشتغل مع vector PB. And I get then the solution of my system using forwards and backward substitution. Okay. Any question on this? Okay. So we continue this chapter tomorrow, hopefully.
Thank you, doctor. Goodbye.
Welcome. Bye bye.